Okay, so what I've built out here is some extra columns for both tails and one tail. And I've already calculated these in my calculator. So for a 90% confidence level, that means I have 0.9 in the middle, and I've got 0.10 or 0.10 for both tails, so 0.05 for one tail. So then what I have done is I've taken the inverse norm of 0.05. So inverse norm of 0.05 is 1.645 when I round to 3 decimal places. Okay? So I'm calculating 94% confidence interval means 6% in the tails, 3% in each tail. I'm going to try to stop saying percents because we do need to get more comfortable with these decimal values as well. So from each confidence level, I'm finding out what is the alpha. So this is the alpha, the area in both tails. And then the area in one tail is the alpha over 2. And that is what I am calculating the inverse norm of to get these values, and I'm rounding them to 3 decimal places. So these are our critical values. So I might refer to this in the future, page 5 of chapter 9 notes. It's just a little handy reference sheet. If you like to use the tables, we can find this information from table 7. Again, at the very bottom of table 7. What is in the top of table 7 is the area in the right tail. So these numbers across the top will correspond with this column. How much area was in one tail? So for example, for a 95% confidence interval, I have 0.025 in each tail. So that's right here in the middle, 0.025. So my critical value of Z is 1.960. Okay, that's what I found right there. The table won't give you everything. For example, if I want this 94% confidence interval, I have 0.03 in each tail, but there's no 0.03 across the top. So that's why it's helpful to know the inverse norm function as well, because sometimes you will have to use that one. But for some of the common ones, if you want to use the table, that's another option for you. Okay, I think that's all the prep work we need to build our own confidence intervals. So now we have some examples where we're going to put all of this together, okay? What is p hat? What's the point estimate? What's the margin of error? How do I find this z? What about q and n? So pulling out all of our information from the question and putting it all together. Here's how we're going to talk about these. Once we have found the values, here is the sentence that we're going to write about each one. So each of these bolded items, 1, 2, 3, 4, 5 places in that sentence in quotes, are going to be replaced with information specific to our question. So we're going to say how confident we are that the true population, whatever, proportion or mean. So in 9.1, it's proportion P. In 9.2, it's going to be the mean, mu. And we're going to talk about what scenario it is, and then we're going to say it's between this number and that number. So here's what we have. We have a sample of 500 nursing applications, including 12% of them that were from men. So could we figure out what percent were from women? Sure. We don't know if we need that yet, but that's what we've got so far. Only 12% of the nursing applications were from men. Find the 90% confidence interval of the true population proportion of men who applied to the nursing program. So this 500 is our sample size. That is our N. This 12% from men, that is our sample proportion. So that is our p hat already calculated for us. We just need to turn it from percent back into decimal. And so I referred to this briefly before. The q hat is 1 minus p hat. So if 12% were from men, then 0.88 or 88% is the proportion of women. That's what that represents. So that takes care of our first sentence, right? The 500 and the 12%. The only other number in this question is the confidence interval percent. So we know it's a 90% confidence interval. I'm going to work this one out kind of by hand and kind of show you the steps that we take to get there. So since it's a 90% CI that we're looking for, that tells us what alpha is. Alpha is 0.10. It's the other 10%. So then that tells us that alpha over 2 would be half of that, 0.05. And then that tells us we use all of this information to find the z alpha over 2. Okay, so N, P, and Q are parts of our formula that we're going to need. Alpha is not really part of our formula we need. It just helps us get this z alpha over 2. So z alpha over 2 is going to be the inverse norm of the 0.05. Okay, and we're going to make it positive. Okay, so that's fine. That's kind of the steps we take, but we just did this. We just did this in our table. So on page 5 of the chapter 9 notes, when it was a 90% confidence interval, we knew that the z alpha over 2 was 1.645. Or from table 7, we know that that's what that is. So it's up to you whether you want to write these steps. I'm really fine either way. If this helps you kind of make sense of what the z alpha over 2 is, that's great. I'll probably write it out for another couple questions, and then I'll probably just skip ahead and say, hey, 90% confidence interval, z is 1.645. Because we're doing that same calculation over and over. So it really is something that we can just use as like a table of reference values. Okay, now we're going to use that lovely formula that was back a few pages ago, but I'm going to break it up into a couple of parts. So this is how I always do these. First, I'm going to identify the point estimate. Since we're working with proportions, and we did see the keyword proportion in this question, so if this question wasn't in section 9.1, we would still know it's a proportion. Our point estimate is the sample proportion, which is the p hat. So that is the 0.12. Our margin of error is the other part of that formula. And the formula for that is z alpha over 2 times square root of p hat multiplied by q hat divided by n. So now we have 1, 2, 3, 4 values to plug into this part of the formula, and we should have them already over here. So this is kind of the layout I set up. I find all my variables on the left, and then I start working with my point estimate and my margin of error. So z alpha over 2 is 1.645. Then I've got a big square root. P hat is 0.12. Q hat is 0.88. And this was from a sample of 500 nursing applications. My N was 500. I am going to want to do all of this in one step in the calculator. I want my answer to be as precise as possible, and I don't want to have to round until the end. So I don't want to have to like multiply these and write down what that is, and then divide by 500, and then square root, and then multiply by this. I just want to type it all in. So that's what I'm going to do. So 1.645. Then we grab our square root, 0.12 times 0.88 divided by 500. So you can either use parentheses or the time sign. I think the time sign is just saves you a couple keystrokes. So our margin of error is 0.024. I'm going to round to 3 places. So now if we go back to the way our formula is set up, our confidence interval, our lower bound and our upper bound, are found by taking the point estimate and adding and subtracting the margin of error. So I've got 0.12 plus or minus 0.024. Always do the minus first because that's going to give you the lower value. I generally type them in at the same time. Okay, so my lower bound is 0.096. And my upper bound is 0.144. That's the one way to rate the confidence interval. I've told you that the way I prefer is with an inequality. So 0.096 is less than p, not p hat, but the real true p. And the p is less than 0.144. So this is our confidence interval. Most of the questions will ask for 2 parts. They're going to ask us for the confidence interval and also to interpret it. So interpret it means explain what it means with words. What are these numbers? What's the P? Okay, so that's where we're using this sentence up here. So we are This was a 90% confidence interval. So we are 90% confident that the true population, we were working with proportions, I always want to confuse population and proportion. It's those long P words. We are 90% confident that the true population proportion of scenario, of what? Okay, so what was this proportion we were talking about? It was talking about how many of the nursing applicants were men. So the true population proportion of male applicants to the nursing program is between what and what? Is between 0.096 and 0.144. So here's the values we filled in. We filled in that it was a 90% confidence interval. We filled in that we were working with proportions, not means. Here was our scenario, male applicants to the nursing program, and here was our lower bound and our upper bound. So those are the 5 values that you put into that standard statement to get your interpretation. Okay, we've got 2 more of these, and then we look at one other additional topic for 9.1. 9.1 is a long section. Once you get 9.1, the rest of chapter 9 becomes a lot more simple. In 9.2, we do the same kinds of things, but with different formulas. And in 9.4, we're just putting it all together and kind of looking at comparing and contrasting 9.1 and 9.2. Okay, sleep apnea is a disorder in which you have one or more pauses in breathing or swallowing while you sleep. So it makes you not sleep as well, right? You're waking up or not breathing or different things going on. In a study of 320 individuals who suffer from sleep apnea, it was found that 192 also had gum disease. Find the 95% confidence interval to estimate the proportion of individuals who suffer from sleep apnea who also have gum disease. So really, if you just look through here and look at the numbers, there's a 320, a 192, and a 95%. So which one is the full sample size? How many people were surveyed? 320 is your N. It was found that 192 also had gum disease. So 192 is important, but that's not quite what we got last time when they told us 12% of the applicants were male. So instead of having a percent, we have an actual number. So 192 is not our p hat, 192 is our x. 192 is the number in a certain category. So we're going to use the 192 and the 320 to find the p hat. So p hat is x over n, 192 over 320. Hopefully a bunch of these calculations come out nicely. MyStatLab will tell you how far to round if they don't. This one comes out as 0.6. 0.6. Whenever you're looking at P, I think it's a good idea to just quickly think of Q. So Q is 1 minus P hat. So 1 minus 0.6 is going to be 0.4. So 60% of the people that had sleep apnea also had gum disease. 40% of the people that had sleep apnea did not have gum disease. And so all that has come from the 320 and the 192. X, N, P hat, and Q hat. Those are all related. Then we have the idea that it's a 95% confidence interval. From that, you can tell alpha is 0.05. So alpha 2 is 0.025. So Z alpha 2 over 2 is inverse norm of 0.025. And we use the positive value of 1.960. But oh gosh, that was in that table. Okay, so all of this is kind of optional to you. You really just need to get to the idea that if it's a 95% confidence interval, your Z, your critical value of Z is 1.960. Now we're going to start to put it all together. Point estimate is P hat. That's something we know. 0.6. Margin of error. I think it's good to write down this formula a little bit. Even though you don't have to memorize it, it just helps you get more comfortable with it. It kind of helps your brain have this repeated motion of what number goes where. So copy it from your first couple pages of the notes where you have the formula. Z alpha over 2 times square root of p hat, q hat over n. We have all those values now. 1.960 times square root of 0.6 times 0.4 over the n of 320. And again, enter this all at once just to keep your precision and leave your rounding to the end. So our margin of error is 0.054. Our point estimate is 0.6. Our margin of error is 0.054, so we're going to add and subtract that. So these are our lower and upper bound. So we could say 0.546 to 0.654. I think that is a lot of the time how MyStatLab has you type it in. But what I want to see on your written work is 0.546 is less than P, because that tells me you know you're dealing with a population proportion here. And our upper bound is 0.654. Okay. So this question just said to find the interval. It's also a good idea to interpret, but it didn't ask it. It didn't ask us to interpret. It just said find the confidence interval to estimate the proportion of individuals who suffer from sleep apnea who also have gum disease. So if I was going to interpret this one, I would say we are 95% confident that the true population proportion, you can steal your wording from up here, of individuals who suffer from sleep apnea and also have gum disease is between 0.546 and 0.654. Okay, another one. This one looks pretty short. Again, there's just a few numbers given to you and you have to identify what's what and put them all in the right spots. 860 of 1,100 males believe they are stronger than their wives. Find the 80% confidence interval for this and interpret the answer. This one's kind of funny. Stronger in what way? It doesn't say, but we'll just go with what we've got here. So 860 out of 1,100, those are some key values, right? Out of 1,100 is telling you your total is 1,100 people that were surveyed, 1,100 males that were surveyed. And 860 is your X. And so we use those to find P hat. $860 divided by 1,100. Ugh, okay, that's not so pretty. So I'm going to round to 3 decimal places. 0.782. Okay, I'm going to stop showing all the steps, okay? So I did the first few where I showed Q hat is 1 minus P hat. Now I'm just going to simplify, okay? So I know P hat and Q hat have to add up to 1. So 1 minus 0.782 is 0.218. So Q is 0.218. And this is new. We have an 80% confidence interval. That wasn't on our little chart, so I guess we have to actually figure this one out. That would imply that alpha is the other 20%, 0.2. Alpha over 2 would be 0.10. And so Z alpha over 2 I can find by taking the inverse norm of 0.10 and using the positive value. Ooh. And so that Z-score is 1.282. Okay, so point estimate is P hat, which is 0.782. Margin of error is C alpha over 2 times the square root of P hat, Q hat over N. So 1.282 times the square root of 0.782 times 0.218 divided by the sample size of 1100. And so our margin of error is 0.0159. We'll call it 0.016. So 0.782 plus or minus 0.016. So here are my upper and lower bounds. So I'm not going to write the interval notation now. I'm just going to write the answer I want. 0.766 is less than P, which is less than 0.798. So that is my confidence interval. This time they did tell me to interpret it. Okay, so I'm going to interpret here. We are, this time, only 80% confident. So interpret means writing this sentence. We are 80% confident that the true population proportion of, what's the scenario? Males who believe they are stronger than their wives is between 0.766 and 0.798. So again, it's that straight from the sample. How much confident are you? Is it proportion or mean? What's your scenario? This is the wordiest part. And what are the two values? Okay, so that's the interpreting piece. I think this question's kind of funny. If it's physical, then maybe those males are justified, but I think we need a little more information here. Okay, so that is building a confidence interval. This is I know this section is very long, but this is a huge chunk of the whole of chapter 9. So just kind of take your way through it step by step. If you're understanding 9.1 really well, then you're almost finished with the whole chapter, to be honest. The other piece that we're going to look at is error. So we know there's always some error. We know we're never going to be 100% confident. So let's look at that error a little bit more. We have a formula here that is going to allow us to figure out how big of a sample we need in order to keep our error within a certain bound. So determine the sample size necessary for estimating a population parameter within a specified margin of error. So E is going to be the margin of error now. And that was that part of the formula, right? So our margin of error is how close we want to be to the true value. We're going to solve this algebraically to get the n by itself. So I don't know if you want to see that or not. You would divide both sides by z alpha over 2. And that would give you p hat q hat over n. And then you would square both sides, and that would get rid of the square root. And then you would flip both sides. So you'd have n over p hat q hat equals z alpha over 2 over e squared. And then you'd multiply both sides by p hat q hat. And they'd cancel out and move to the right. And so this is the algebra that we do. You don't need this. I just thought some of you might be interested. This is the algebra that we do to turn this formula into this formula. Okay. This is important. We are always going to round up to the next whole number. Okay. So this is talking about sample size. So if you get a sample size of 3.2, are you going to interview 3.2 people? No. But 3 is not enough because it said 3.2. So you're going to go up to 4. Here's another little note. This is strange, but it pops up from time to time. If they don't give you a p hat, you're going to use 0.5. And then that would mean that your Q hat would be 1 minus 0.5. Your Q hat and P hat would both be 0.5. So you have to look first and see if they give you one, but if not, then you're going to do that. So here's a couple. These are pretty important notes. So we have a researcher who wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of true proportion. So they want their error to be within 2%. Find the minimum sample size necessary. So when they say find the sample size, you know that they're saying what is n. So you're using the n equals formula. Okay? So that's what we're looking at. So let's see what we can find up here. We know we have a 95% confidence interval. So I'm going to start using my shortcuts. Let's see if I can find that page 5 of the table. If I have a 95% confidence interval, my z alpha over 2 is 1.960. So that's one of the things I need for my formula, right? A previous study shows that 40% of those interviewed had a computer at home. So that is the sample proportion. That's the proportion of people that had a home computer from the people that they actually surveyed. So that is the P hat. So from there, you can find the Q hat. The Q hat will be the other 60% or 0.6. And then we've got our other number is this 2%. Well, what have we identified up here? We've got our Z, we've got our P hat, Q hat. That's the E, right? The error. Okay. So this error of 2%, we're going to also convert to a decimal. Don't make it 0.2, that'd be 20%, right? 0.02. 2 divided by 100. You can do it that way as well. So there's all of our values that we need. Now we use this new little formula. P hat times Q hat times Z alpha over 2, the critical value on top, the error on the bottom, and that fraction squared. So we got 0.4 times 0.6 times 1.960 divided by the error of 0.02 and the fraction squared. And again, I'm going to type this in all at once. I don't want to have to write down all these crazy numbers with decimals onto my paper. I just want to do the whole thing. You can do parentheses or time signs. I am going to do this part in parentheses because of the exponent there. Okay, so the n, whoa, what did I do wrong? Do you see it? I didn't put in this decimal. That's pretty big. 1.960. Okay, so my n is 2304.96. So what's my sample size? I'm always rounding up. So 2,305 is how many people I'm going to have to survey to show that my estimate is within 2% of what it really is. Okay? So round up, okay? Not just round, but round up. This one would naturally round up, but even if it was 2304.2, I would still round to 2305. Okay, got one more like that. There's not really an interpretation piece to this sample size question. They're really just saying, how big does the sample have to be? You have to survey at least this many people. So there's not a lot of words to go along with it. That just is your sample size that you need. The same researcher wishes to estimate the proportion of executives who have a company car. She wants to be 90% confident and be accurate within 5% of the true proportion. Find the minimum sample size necessary. So what do we know? We know 90% confidence interval. We've got a table for that, right? I keep losing mine. 90% confidence interval. That means my Z alpha over 2 is 1.645. She wants to be accurate within 5% of the true population. So E is 0.05. What else do I know? Nothing. What else do I need to know? Well, they want to find the sample size, so it's the n equals formula. P hat Q hat Z alpha over 2 over E